Hi students. So in our previous module we studied how to balance a redox reaction with the help of oxidation number method. And in this module today we will see the second method to balance the redox reaction. So which one was it, second method? Yes, it is half reaction method, which is also called as ion electron method. So to balance with the help of this method, there are certain steps involved. So let's just first understand the steps and then we'll jump to the example. So my very first step is to assign the oxidation number to the elements or the species involved in the redox reaction. So as students, let me remind you, in our previous method, that is oxidation number method also, our very first step was to assign the oxidation number to all the elements involved in the redox reaction. So we'll first assign the oxidation number. The next step will be to divide the equation into two reactions, that is oxidation half reaction and reduction half reaction. So your students, as the name suggests, half reaction method, we are dividing the equation into two parts, that is oxidation half reaction and reduction half reaction. Once we are done with dividing it into two different reactions, we will balance the atoms. Yes, so our third step will be to balance all the atoms except for oxygen and hydrogen. And once we are done with that, we will balance oxygen and hydrogen similarly like previous method by adding water and hydrogen ions respectively. The next step will be to balance the charges. Now students, here what we'll do is we'll balance the charges by adding electrons either on the left hand side of the reaction or right hand side of the reaction. And finally, our last step will be, in case if the reaction is in basic medium, we don't think but we add OH minus equal to the H plus ions present in the reaction to both the side. So students, what are the steps? First step to assign oxidation number. Second step to separate the reaction into oxidation and reduction reaction. Third step is to balance all the atoms first and then balance oxygen and hydrogen atom. The fourth step is to balance the charges by adding electron, and then we add both the oxidation and half reduction reaction. And finally, if the reaction is in basic medium, we add OH minus equal to H plus ion in the reaction. So let's start with an example to understand how to balance with this method. So here we have a reaction where we have to balance ACO3 minus forming SeO4 minus and Cl2 forming Cl minus. So first step students, yes, we will assign the oxidation number, where if we see the oxidation number of selenium in the reactant is 4 and that in the product is 6. If we see chlorine, the oxidation number in the reactant side is 0 as it is in its elemental state, and that in the product is minus 1. Students, next step is nothing but if we identify whether it's a reduction reaction or oxidation reaction. So here if we see chlorine, it's forming 0 to minus 1. Hence we can say it is a reduction reaction. Whereas selenium is going from 4 to 6, we can say it's an oxidation reaction. Our next step will be to distribute the reaction into two different reactions, that is oxidation half reaction and reduction half reaction. So oxidation half reaction is nothing but selenium reaction and the reduction half reaction is nothing but chlorine reaction. The third step students is to balance first all the atoms and later balancing oxygen and hydrogen. So in the first case, that is oxidation half reaction, selenium is already balanced on both the side. Whereas chlorine, we have 2 on our left hand side and just 1 on right hand side. So we will balance it by putting 2 on the product side. Next step is to balance the oxygen atoms and hydrogen. So here for the oxidation half reaction, on reactant side we have 3 oxygen, whereas that on product is 4 oxygen. So we will put 1 molecule of water on the reactant side, and to balance hydrogen we will put 2 hydrogen ions on the right hand side. For chlorine, there is no such addition of water required as there is no oxygen atom present. The next step is nothing to balance the charges by adding an electron. So how do I do that? Students, for oxidation half reaction, if you see, the charge on SeO32 minus is -2, whereas water molecule is neutral. So on our reactant side, we have charge of -2. Whereas in product side, we have -2 for SeO4 -2 and +2 for hydrogen ions. As each hydrogen carry +1, 2 hydrogen will carry +2 charge. So overall charge on my right hand side is -2 and left hand side is 0. How do I balance these two? By adding electron. Students, electrons are negatively charged, and since the difference between the two is just 2, I need to add 2 electrons. Now where do I add this 2 electron? Suppose I add it on reactant side, -2 plus 2 electrons becomes -4. Whereas if I add it on the product side, 0 plus 2 electron, that is 2 electron will have charge of -2. So that becomes, if I add 2 electrons on the product side, I get -2 as the number. So hence we can say the charges are balanced for the oxidation half reaction. If we talk about reduction half reaction, students, it is 0 and -2. So the case is almost similar. Now I need to add 2 electrons to my reactant side, and thus the charges will be balanced for both the reactions. Next step, student, is to do nothing but to add the 2 electrons on the reaction. So for the oxidation half reaction, we add 2 electrons on the product side, and for the reduction half reaction, we add 2 electrons on the reactant side. The next step is to add both the reactions. So when we add both the reactions, you can see there are 2 electrons both on the reactant side as well as on the product side for both the reaction, oxidation and reduction reaction. So since the number of electron lost in oxidation half reaction is 2 and the number of electrons gained in reduction half reaction is again 2, we do not need to multiply with any factor. So we can just cancel the electrons in both the reaction and we get some net reaction like this. Now students, if the question would have been in acidic medium, we would have stopped our reaction here only saying it's a balanced reaction. But our question says it's a basic medium. So now the additional step for the basic medium will be to add OH minus equal to H plus ions. So in our next step, we will see how to add OH minus. Students, if you see on the product side, we have 2H plus. So I need to add 2 OH minus on both the side of the reaction. So we add 2 OH minus on both the side. But students, if you see the highlighted portion here, 2H plus and 2 OH minus forms 2 water molecule. So instead of writing 2H plus and 2 OH minus, we can simply write it as 2H2O in the reaction. Now on the reactant side, if you see, there is just 1 water molecule, and on the product side we have 2 water molecules. So I can just write it as 2 water molecules separately and cancelling both the water molecules on each side of reactant and product side. So the final reaction what we get is 2OH minus plus SeO3 2 minus plus chlorine, giving us SeO4 2 minus plus 2Cl minus plus H2O, and we can say the redox reaction is balanced. So this is how we balance it with the help of ion electron method. Next module we will see the applications of the reactions. Thank you.